G'day ladies and gentlemen, and thank you for watching my video. I'm Henry Kister. I'm the instructor in the Practical Distillation Technology class by ICME. A few words about my background. I'm the Director of Fractionation Technology for Fluor. We are a major engineering and construction company, and what I usually get involved with is anything to do with distillation. It includes troubleshooting, includes field consulting, controls, revamps, a lot of revamps work. Not so much fresh design, this is kind of a lot of that is cookbook, but a lot of these other things that I do. And I've been in the business for about doing distillation for the last 40 years or so, and out of these I've been teaching for the last 30 years. So I kind of learned I've been through the school of hard knocks on that. And anyway, and also I'm a proud graduate of the University of New South Wales in Sydney, Australia. The whole purpose of this class is to provide participants with the tools to be able to address their own distillation problems. And we cover a whole bunch of topics. We'll start off with simulations. Okay, how to make sure the simulation is correct. Hey, I've got a client right now sending me a simulation that doesn't make any sense. Why doesn't it make sense? Because they did not check it against plain data. Now, how do you check it against plain data? We're going to cover that at length. Also, sometimes there's non-idealities. Non-idealities, what do? Well, for example, if you put a small amount of methanol, which is a high boiler, with a big composition of C3 propylene propane, you think the high boiler will go to the bottom. It doesn't, it goes to the top because the hydrocarbons repel the methanol. Again, we talk about these mechanisms and we make sure that everybody understands it so they can apply it to their own situation. We talk about trays. And we show a video, we show what it looks like, what flooding looks like, different types of flooding. You've got jet flooding, you've got downcomer backup flooding, you've got system limit flooding, all of these. They're different and each one takes a different corrective actions. So we're going to talk about each one of them. So again, so that the participants will be able to figure out what is the kind of flooding that they're dealing with and how to tackle it and what they can do to overcome that. So that's what we do. We do the same thing about packings too. We look at the different types of packings that we do have. Also, what are the main problems with packings? I'm not sure that everybody realizes, but 80% of all pack tower failures are because of distribution. Okay, and you think, okay, well, yeah, we know that. All we need to do is level the distributor. If you look at the statistics, that's not the number one issue. Number one issue is plugging with fouling. How do you prevent that? The second big thing is overflow. That's when the liquid in the distributor gets over the top of the troughs. That causes maldistribution. So these are the things we're going to talk about. Again, how to identify it and what do we do? What kind of corrective actions do we need to take for that? We talk about fouling. How to monitor your columns for fouling. When do you know that the fouling starts to take place? And what can you do to avoid fouling? The strays and packings that tend to foul more than others. Okay, which are they and what can they do for you? So this is the idea of that. We talk about foaming. A lot of time when something doesn't work, yeah, it's foaming. And that's something, again, is it or is it not? How do we identify foaming and what are the corrective actions? Okay, we're going to talk about revamps. Okay, we want to increase the capacity of our tower. We want to get better specs out of the tower. What do? Everybody says, well, we go to the vendor. Yeah, the vendor's got a lot to offer. But a lot of the time, you've got to critique what the vendor is coming up with. And again, this is the kind of things we're going to tackle out there. And we're going to talk about controls. Everybody says, yeah, controls, that's pretty straightforward. But there's a lot in the basic controls that needs to be done for the advanced control to work. And we're going to talk about troubleshooting the controls. These are the ones. Which methods work, which methods do not. Pressure control. A lot of the time, the whole stability of the column depends on your pressure control. Where is the best temperature control point? Again, we address that thing. Reboiler control, condenser control. We talk about all these things. Also, we talk about column failures. What are the common causes of column failures? One of them, people don't realize that. If your liquid level at the bottom gets above the reboiler return, the vapor from the reboiler is going to blow it right up the column. It's going to flood the whole column and very often to lift trays of their supports, or they can overfill the column with liquid pouring into the flare system or into the vent system. And we had a disaster out here in the US in 2005 when something like that happened. So again, we talk about these things. And one other thing, and also one thing, self-venting flow. Very often draw pipes are not sized for self-venting flow and cause a whole bottleneck in the column. And people put high capacity trays, they're not going to solve the problem, because the problem is that lines are not big enough. And again, we're going to learn how to identify that. Last but not least, we also have some time to discuss your unplanned problems. After 5 o'clock, that's not in the agenda, but bring your planned problem. We'll talk about it. I'm not sure that I'll be able to solve it. In fact, probably won't. If you struggle with it for about half a year, we're not going to solve it in 1 minute. But we might give you some leads from other people that struggle with something similar. This course is the bread and butter for process and operation engineers involved in distillation. Our survey showed that failures in distillation are repetitive. People repeat the same mistakes over and over again. And the whole idea is to familiarize you with the mistakes that other people made so that you would make it. Now, if you learn from your own mistakes, you're smart. But if you learn from other people's mistakes, you are wise. And our objective is incorporate that wisdom into this 3 days course. And we're talking about all levels of experience. We've had people that very often attended the course 3 times. And they tell me each time they learn something different. One time when they're graduate engineers, they pick some type of ideas up. Then when they're about 5 to 10 years experience, they pick other ideas. Then when they got 20 years experience, they pick some other ideas. So there's different levels of experience. It works for all of them. Okay, now, so these are the main people, but it's also very important for other type of engineers, research engineers. Really, they need to know what are some of the issues that can happen, that they can avoid them when they develop new processes and new ideas and new technologies. Also, control engineers. Again, what are the background to controls? What are some of the problems that people have, and how they interact with the process? Very important for them as well. Mechanical engineers. Again, they very often talk to process engineers, and they need to know what process engineers are saying when they work with them. So and we had also maintenance people, chemists. Believe it or not, one of the greatest developments in packing technology, the pouring, it's been revolutionary back about 80 years ago, was not by a chemical engineer, it was by a chemist that understood chemical engineering. So again, very beneficial for chemists as well. Managers, yeah, believe it or not, we've had people that managers got to, once they become managers, they obviously don't do run simulations or something. But when somebody tells them that the simulation does something, they'll be able to say, wait a minute, that doesn't make sense. That's the role of a manager. So we had managers attending that and very happy with it. And operators. We have operators. Obviously, they're not going to be interested in simulations. They call that theory. That's not good for them. But many of the other things, the controls, the hardware, and stuff like that, that is going to be very beneficial for them. Our statistics of failures in the chemical industry indicated that the biggest bottlenecks in columns are not your trays, are not your downcomers, are not your packings, but they're things called points of transition. A point of transition is any place where a stream enters the column or a stream leaves. That includes your feed points, that includes your draw points, that includes your packing distributors, that includes the region below the bottom tray. These are points of transition, and these are the biggest bottlenecks. And we've seen many cases in which people put high capacity trays in the column. They didn't get high capacity. Why? Because the bottleneck was not in the column, it was in a point of transition. It was in a draw point, in a chimney tray, in a feed, something like that, feed entering a distributor incorrectly. These are the ones that will cause make or break it. We've seen first of a kind processes where chemists work on them for years and came up with something, but it didn't work. Management started suspecting, oh, the chemistry is wrong, everybody. Once we got to troubleshoot it, there was nothing wrong with the chemistry. Some line was not sized for self-venting flow. That's what bottlenecked the whole process. And once we fixed that, the process was working. The chemistry was wonderful. If this course can help you solve one distillation problem, only one, or avoid one case of misdiagnosis or damage or fouling in your columns, then it will more than pay for all your time and for your travels.